So looking here at 2017, question 9. So define a base according to Branston Lowry. So a base is a proton acceptor, conjugate acid-base pair, any pair that differ by one proton. Then you're asked what is the conjugate acid of H2O. So remember, a base changes into a conjugate acid when it accepts a proton. So my conjugate acid there is going to be H3O+. Then you're asked to define pH, so minus log to the base 10 of my H+ ion concentration, and just make sure you put in moles per litre. And then we're asked the pH values of 0.210 molars of sulfuric acid, hydrochloric acid and methanoic acid are. So I'm just going to write in here what I'm told. H2SO4 is 0.70. HCl I'm told is 1.00. And methanoic acid, HCOOH, is 2.37 respectively. And you are asked here then to in terms of hydrogen ions, account for the difference in the pH values. Okay, and firstly I'm told or asked between 0.10 molar of HCl versus 0.10 molar H2SO4. Okay, so the first thing here that I'm going to have a look at is my HCl, and that HCl splits into H+ plus Cl minus. However, if I look at H2SO4, that's going to split into 2H+ plus SO4 2 minus. Okay, so my pH for this, my ratio is 1:1, so 0.1 is to 0.1, and my ratio here is 1:2. So I'm going to have 0.2 moles of sulfuric acid. So pH here is minus log to the base 10 of 0.1. My pH here is minus log to the base 10 of 0.2. So that's going to give me a pH here of 1 and a pH here of 0.698, so 0.7. Okay, so that's accounting for the differences there. Okay, the reason why is because your H2SO4 produces 2 H+ ions, HCl produces 1 H+ ion. Okay, so that's it fully explained there. I would go through your pH equations there. Okay, the next thing then that we're asked is part 2. So the difference between 0.10 mole of HCl versus 0.10 mole of methanoic acid, which is HCOOH. Okay. So just if you kind of look at the difference here, HCl is a strong acid and HCOOH is a weak acid. Okay, so the reason why is because HCOOH is a weaker acid than HCl. So again, you can just explain that there with words. Okay, that's sufficient for this one. So then you're asked to use the pH value given for 0.10 molar of methanoic acid to calculate, and you're asked the value of the dissociation constant Ka. Okay, so I'm asked here to find Ka. So the first thing I know as well is that I have 0.10 molar, but I also know my pH because I'm told in the question that that's 2.37. So I'm going to work out my amount of H+ ions that I actually have. So remember, pH equals minus log to the base 10 of my H+ ion concentration. So my H plus ion concentration is equal to my antilog of minus 2.37, and that's going to give me minus 2.37, antilog gives me 0.004266. Okay, so now I use my H plus ion concentration is equal to the square root of Ma by Ka. H plus is, and I'm just going to go 4.266 by 10 to the minus 123, equals the square root of Ma, which I know from my question is 0.10, and Ka is what I'm looking for. So what I'm going to do is I'm going to square both sides. So when I square my my H plus, I get 1.8 by 10 to the minus, and it is 1, 2, 3, 4, 5. And then I'm going to get Ka by 0.10. So I divide both sides by that, and that gives me an answer of 1.8 by 10 to the minus 1, 2, 3, 4. So that here is my value for Ka. Okay, then the last part of this is the pH of a 0.05 molar solution of methanoic acid. So here I'm going to use H plus equals the square root of Ma by Ka. So my H plus ion concentration in this part, I'm told it's 0.05, and I've worked out my Ka to be 1 by 10 to the minus 4. So when I get the square root of 0.05 by 1.8 by 10 to the minus 4, that gives me 0.003. So my pH is equal to minus log to the base 10 of my H plus ion concentration minus log to the base 10 of 0.003, and that's going to give me an answer of 2.52.